We look again at the unit circle, and we take just any point. This looks like it's pretty close to a radian, although it's a little bit short. But this is just an arbitrary point out here on the circle at some angle theta as measured from the positive x-axis. This point has coordinates x and y. The x-coordinate can be seen as a projection down here. The x-coordinate is the coordinate of this point, or it's this distance, this displacement from the origin. The y-coordinate is this point, or this distance from the origin. We can see a couple of things. If we isolate this triangle, we have x as the base, y as an altitude of a right triangle whose hypotenuse corresponds to the radius on a unit circle. That radius is 1. So we see that for a unit circle, for a point on the unit circle, by the Pythagorean theorem, the square of this and the square of this has to equal the square of the hypotenuse. X squared plus y squared is 1. Now, for the angle theta, whatever x is, we're going to call that the cosine of theta. So here's the cosine of theta. If the side here is 1, then this x is the cosine of theta, and y is the sine of theta. That's the definition of the sine and the cosine. We can see that it follows from that definition. We could rewrite this triangle. Instead of x and y, we could rewrite cosine theta and sine theta here. And we see that the sum of the squares of these two things is equal to this. Sine squared theta plus cosine squared theta equals 1. That's a very important identity. And we need to understand exactly where it comes from and how it relates back to the unit circle definition.